Nvidia says RTX is on quite a lot, but what does that even mean? Ray tracing is RTX? Or is it DXR? Or is DXR actually RTX? But if that's the case, then how does AMD do it too? Well, Nvidia's marketing machine may have gotten those little letters out in front of everyone with big energy, but when I look around the internet, I see quite a few people still confused by what is and what isn't RTX. The truth is, there's a lot more to what Nvidia is referring to as RTX. Quite a bit more, actually. And in this video, I intend to help you understand what all the fuss of RTX is about and cover all that it encompasses for now. And no, it isn't just ray tracing. Now we're going to kick off today's explainer with the very basics to set a foundation of what RTX is. From a high level, RTX is a few things. In fact, just like my previous explainer where we covered AMD's Fidelity FX, RTX is a very similar story. Now, RTX is the moniker for an entire set of hardware and software features that Nvidia has supported since the introduction of the RTX 20 series. Basically, if a GPU has the letters RTX in front of it, it supports these features. Ray tracing in itself is not RTX. You're likely thinking about ray tracing in Microsoft DirectX or Vulkan. Now that's a very important distinction, as many still think all of ray tracing in general as RTX. That's the result of Nvidia's heavy marketing and being the first to market with those features. So part of RTX is ray tracing. Yes, as the most obvious feature for those who are even remotely familiar with the terminology, but there are dedicated hardware features that make a card RTX capable. The RTX umbrella supports features and technologies like deep learning supersampling, Nvidia Broadcast, and some tech that hasn't even come to fruition yet, just like RTX I/O. But what specifically about the hardware side of things that makes a graphics card fit the RTX moniker and differentiate itself from the previous GTX cards? Well, it's a simple explanation, but a GPU basically needs to be able to support all of the RTX functions on a hardware level. The two most prominent being the ability to support hardware-based ray tracing through the use of Nvidia's RT cores and the artificial acceleration cores known as tensor cores. Now first up to bat are those RT cores and how they handle ray tracing functions within the GPU core. When it comes to real-time ray tracing, the speed of ray calculations is key. And it's also extremely difficult, so it needs dedicated silicon for the process. In short order, the RT core handles the calculations that are needed to be done in each light probe in order to trace the ray, for example. Now, dedicated hardware really was needed to make this possible, and it can be done on traditional shader silicon like we're used to having for years, but this is exponentially slower when done on traditional GPU shaders, and that's why they suck at it. But what does ray tracing do for gamers? Well, in short, it adds the ability to have gorgeous, realistic lighting effects in games. At one extreme, you've got full path trace games like Quake 2 RTX or even Minecraft with RTX that no longer render the game using traditional rasterization. The results are absolutely stunning in accurately lit and displayed worlds, but that's extremely taxing on even the most powerful GPUs, so games commonly use a hybrid rendering approach. Now, hybrid rendered games still mostly use traditional rasterized graphics, but add in some ray traced effects, such as ray traced reflections for accurate reflective surfaces, and there's also accurate shadows, and the most impactful feature in my opinion, ray traced global illumination, making games like Metro Exodus Enhanced Edition really shine. Now, all of that does come with a pretty steep performance penalty, however, and that has been considered also with the design of these RTX cards. And speaking of which, the other main hardware component is the inclusion of tensor cores that are used for enhancing matrix operations and used for deep learning and inference operations. Now, this makes them ideal for workstation applications, research use, and, in the interest of most of our audience, gaming performance acceleration through the use of deep learning supersampling or DLSS. Now, DLSS has gone through quite a few iterations and continues to be updated, so always check for the latest information on this one, but at the time of filming, we're up to the DLSS 2.plus series. But what is it? DLSS is a pretty unique anti-aliasing method that utilizes a neural network training to allow games to run at a sub-native resolution without major loss to visual quality. The algorithm takes a supersampled data set that it was trained on to reconstruct the game back to as close as native as possible. In some cases, it actually provides better than native image quality. By simple proxy of rendering the game at sub-native internal resolution before using tensor cores to upsample, DLSS increases performance exponentially at times. We recently tested Doom Eternal as well as Red Dead Redemption 2 to see how the impact of the latest DLSS implementations shifted performance. Now, when these features are added into a game, we often see what amounts to either a generation or a tier up in performance for each card. DLSS 2.0 is definitely good stuff. The biggest drawback to DLSS is that it only works with RTX cards that have those tensor cores on board. So, for now, it's certainly a growing market, but still has a long way to go before it's normal. There's still more to the world of RTX and those tensor cores. Outside of DLSS, the biggest feature for gamers and streamers is going to be Nvidia Broadcast. It's a standalone application that gives access to 3 very useful AI-based features, one of which I personally use almost daily: the noise removal. It's quite astonishing what this thing is able to filter out for recording or gaming with your friends. Now, I'm going to let you in on a little secret. Nvidia did make a standalone app just for this one that works with GTX cards, but I wouldn't recommend trying to use it while gaming at the same time. There are also 2 other features surrounding your camera usage. One is a virtual background that provides the ability to remove your background without the need for a green screen setup. Like most virtual background implementations, you're going to want to ensure that you have a nice contrast between you and whatever's behind you for this one to work best. The other feature is the ability for the camera to crop in the image and dynamically follow your face around. Now, this is more useful for just chatting or streamers or artistic streamers rather than gamers, in my opinion. Now, the last RTX feature that I'm going to touch on today isn't even in use yet and is waiting for the feature from Microsoft to finally be available. Now, that's none other than RTX I/O, which will plug right into Microsoft's Direct Storage API, and this is a feature designed for gaming PCs running ultra-fast NVMe drives and should greatly reduce I/O overhead from the CPU. It will allow data to be moved in and compressed fashion directly to the GPU, leaving the CPU to handle other operations and letting the graphics card handle the decompression. It'll still be a bit before we can see this one in action, so hold on to that one. So, what does it mean when Nvidia says RTX is on? Well, it could mean any of one of the things that we've gone over in this video today. It could be one type of hybrid ray tracing feature, it could simply be DLSS like in the case of Red Dead Redemption 2, or it could be a full-blown path trace game with DLSS like with Minecraft with RTX. Now, if you want to know which it is, you'll have to be sure to check the game and see just what it supports, because each game will be different. Now, I hope you got something out of today's video and will be leaving feeling a bit more certain about what is and what isn't RTX. And if you enjoyed this, please leave a like and make sure you're subscribed here at PCWorld for even more hardware and software goodness.